Hello. Welcome back to my channel. In my first video for algebra, I talked about functions and relations. That was part 1. The important takeaway from that part. Function is a relation which is a relationship between x and y. It has one x related to only one y. So, I will explain a bit more deeply about that. Now, I will give you a new example. Okay. So, we have a new example. So, we have a table. The first column lists cities, and that's our x. We have Albany, Denver, Miami, San Francisco. The second column is for the elevation of the airport. This tells us how far the airport is above the sea level. That is our y. There are different numbers in this column. So, you have 4 parts you need to answer for that problem. The first part is write a set of ordered pairs x, y. Understand that we have to write this as a relation. Recall that in the previous video that I explained that a relation is a relationship between x and y. So, we have Albany and it is related to 285 in the second column. Denver is related to 5883 in the second column and so on. We will go ahead and write these as ordered pairs in the form of x, y. So, the curly brackets are there because it is a set. Remember, the first part asks for a set. Now, there are 4 ordered pairs. Each x relates to its y value. For example, Albany relates to 285. Albany's airport is at 285 feet above sea level. So, I did the same thing for the other 3 cities. That's the answer for part number 1. Next, number 2, we need to find the domain of that relation. Recall that the domain is all of your x values. So, we have 4 x values. So, let's answer number 2. So, again, D, which is an abbreviation for domain, equals curly brackets to denote a set. This set is of all the x values, which are our 4 cities: Albany, Denver, Miami, and San Francisco. Next, number 3, write a range for that relation. So, recall that the range is all of your y values. So, you have 3 y values. Why is that? Notice that 11 appears 2 times. We really just need to write it 1 time. Let's go ahead and answer that part. There are 3 y values because 11 occurs 2 times. So, again, you don't need to write it twice. Just write it once. Now, number 4. Basically, you want to determine if that relation is truly a function. So, recall from the previous video that a relation is a relationship between x and y. But a function is a relation, and understand that x is related to only one y. So, let's look at our table. Is Albany is related to only one y value? Yes. Next, is Denver is related to only one y value? Yes. Next, is Miami related to only one y value? Yes. Next, is San Francisco related to only one y value? Yes. So, the answer for part 4 is yes. The only way for the relation to be not a function is, suppose I do this. I add a number to the table. I added 1003 here. Now, this tells us that the airport at Miami is at 2 different elevations, at 11 feet, and 1003 feet. Now, in the real world, this is impossible for one object to be at 2 different heights, at the same time. So, the whole relation will not be a function. Because Miami is related to 2 y values, which is not allowed for a relation to be a function. There must only be a x to only one y value. Now, I want to continue to go deeper with functions. Now, there will be a function notation. We tend to see something like this. Y equals x plus 3. Now, to change this to function notation, it will look like this. y will be replaced with f of x. This is the formal notation for a function. Now, remember this. F of x can be changed back into y. You will see in future videos where f of x will be changed to y. For example, you want to solve for y. Now, here's a warning. F of x does not mean you multiply f with x. F of x means f is like a machine. You put in x in it. What is inside the brackets is what you will replace x on the right side of the equation. Then you can find your answer, which is your output. Now, I am going to give you an example. So, here's an example. F of x equals 3 times x plus 1. That is our function that we will be working with. Next, this problem asks me to evaluate f of negative 2. So, basically, evaluate means you will be given a number. What you do with that number is put it in your function. So, let's go ahead and do that. I wrote f of negative 2 equals 3, then replaced x with parentheses. Because we will put negative 2 instead of x. Next, follow the order of operations. In this case, we will multiply first. Next, go ahead and subtract. The answer is negative 5. So, this tells us the x value of negative 2 when put in the function will give you an output of negative 5. Next, we will look at a picture of a function which is a graph. You will determine if the graph shows a function or not. Okay, so, we have a graph paper. Suppose we graph a function. This is a line. We want to determine if this is a function or not. We have a special test called the vertical line test. So, what we will do is draw vertical lines. You will see why. See these red lines? You can draw as many lines as you want. You see the green line, that's our function. Notice that the red lines touch the green line only once. So, each red line never touches the line twice, which means every x for that function relates to only one y. I'll give you another example. Now, suppose you have a circle. The circle drawn is not a perfect circle. Again, let's draw red vertical lines. You can draw as many as you want. So, notice that many red lines touches the green circle twice. For example, here at x equals -2. The red touches here and there. So, -2 for x has two different y values. Therefore, this circle is not a function. So, that is the vertical line test and helps you to look at a graph of a function. To determine if it is truly a function or not. Now, with a function, you can determine where it crosses the x-axis or the y-axis. You can use math to do that. I'll go ahead and write some things on that. We want to find the x-intercept and/or y-intercept for the function. It is simple to do. It is a basic concept. The x-intercept means you want to find where the function crosses the x-axis. Next, the y-intercept is where the function crosses the y-axis. There are two parts. Find the x-intercept and find the y-intercept. To find the x-intercept, it is simple. Y will be 0. This is because when y equals 0, it will be on the x-axis. This will allow you to find where the function crosses the x-axis. If we want to find the y-intercept, this means x must equal 0. When x equals 0, it will be on the y-axis, which means you can find where the y-intercept is. I'll give you an example how to do that. This is our function. G of x equals 3 times x minus 12. So, we want to find the x-intercept and y-intercept. So, let's find the x-intercept first. So, this means we want to find where this specific function will cross the x-axis. So, the first step that you want to do is change g of x to y. Now, to find the x-intercept, this means y will be 0. Now, we will solve for x. Over here we have 3 times x minus 12. So, this means first, leave 3 times x. Let's add 12 to both sides. So, when we added 12 to both sides, you can cancel the 12 on the right side. And we are left with 12 equals 3 times x. Now, to get x by itself, we have to divide by 3. Four equals x. Really, it is also x equals 4. This means that x equals 4 on the graph. I will show a graph soon. This means the function will cross where x equals 4 on the x-axis. Next, find the y-intercept. To find the y-intercept, which means x will be 0. So, replace x with 0. Now, 3 times 0 is 0. So, y equals negative 12. So, this means that y equals negative 12 on the y-axis. The function will cross there. So, the graph of that function will look like this. See the graph crossing the x-axis at x equals 4? And it crosses the y-axis at y equals negative 12? Cool, right? So, this is part 2 of the lecture on functions and relations. I will in the next video do the third part, which is the last part on functions and relations. Again, thank you for watching me. Please subscribe if you haven't. Please click on the bell to be notified when my next video has been posted. Thank you for watching. Have a wonderful day. Bye.